Yeah.
Okay, good morning.
Good morning, sir.
How are you? Okay, welcome. Now, today on Wednesday, we are going to do something based on what we did yesterday before we proceed for today's work. And before that, I want to confirm by registering your names to confirm the people who are present today before we proceed. So we start by Doris Akini. Is she present?
Yes.
Good. Then Lisa Abigail, Elizabeth,
Present.
Linda Wamalwa, Juliet Ledima, Sharon Mekesa, then Topista Chemtai, we have Catherine, we have Anango Marion, we have Mekesa Caroline, we have Mandela Masi, Rachel, we have Elizabeth Chepokimei, Samson Migua, Evans Tabarasa, Nyango Sija,
Absent.
Brian, then I have Ruth, we have Brenda, Bethwell, Barasa Roda, and we have Esther Smith. Are they all present?
Yes.
Very good. So that is good. Now, before now we start to do what we want to do for today, we are going to start. So it is vector theory. Then we have the learning outcome. We have the learning outcome. Now the learning outcome is going to be number one, we say, to perform the vector and scalar definition. Then the second one is going to be to perform the calculation involved in vector theory. So those are our learning outcomes that we are going to discuss for today, for today's class. And before that one, before we start to discuss about our learning outcome for today, can we rearrange ourselves? Can we rearrange ourselves to be in good sitting position? Come and sit here. Then let me have a way that I'll be moving to mark something so that I'll be moving. Good, thank you, very good. So we are going to start with the first learning outcome about the vector and scalar definitions. I believe by now some of us know how to define the word vector and scalar, isn't it? So whenever we talk about vector and scalar, whenever we talk about vector and scalar, we have the one that deals with the magnitude and the direction, isn't it? Yes. Then we have the other one that doesn't deal with the magnitude and what? Direction. So in between the two, the vector and the scalar, which one deals with the magnitude and the direction? Yes. Vector. So vector here deals with direction and after we define the vector and the scalar in that manner, we need to know the examples of this vector, examples of vector, and also the examples of what? Scalars. What are the examples of vector? One, just one. And yes. Vector, an example of vector, things like maybe temperature, time, mass, distance, acceleration, velocity. Those ones, like that way. The one that has direction and magnitude. Vector. Now, under vector, examples of this vector that has direction and magnitude is what? Time is there, isn't it? Yes. Then you have also time and temperature. These things can be measured, isn't it? But when we come to the scalar, things like acceleration, volume. This one doesn't have the direction, isn't it? Yes. Yeah, volume. So after we've known like that now, we start to perform. The calculation that involves in vector theory. Right together? Yes. So the calculations that involve in vector theory let us write by saying number one. Let us write by saying number one. A vector can be into two components. A vector can be into two component parts such that vector addition of component, part is equal to the original vector. There are two components. We say now there are two components usually taken. The two components that are usually taken will have the horizontal and the vertical. So this is the vertical and this is the horizontal. So whenever we talk about the vector component, we talk about how we represent them, either vertical or horizontal. Is that okay? Yes. Now we have an example that we say, an example we say a force of 4N, or Newton is inclined at an angle of 45 degrees. Is inclined at an angle of 45 degrees to a second force of 7 Newton. Both forces acting at a point. Find the magnitude of the resultant of these two forces. Find the magnitude of the resultant of these two forces and the direction of resultant with respect to 7N or force. 7N, N is Newton, force by both an angle of 45 degrees. Using the parallelogram method. Using the parallelogram method. So, how do we go about this one? So we have the solution. Now the solution here should help us to interpret the question first. You first interpret the question before you want it out. So the first calculation, I've said that the component are drawn like that, isn't it? So vertical and horizontal. So when it comes here, we draw it like that at an angle of 45 degrees. So our angle will be here, which is 45 degrees. Then we have the forces that have been given for us. That is 5 and 7, isn't it? Is it 5? 4 and 7. So here it is 4n and here it is 7n. Very good. So when we draw that this vector in this direction, this means we have the angle and also the direction of the forces. This shows us how the force is moving. From there, we can extrapolate and use the parallelogram method now to do it, to work it out. We extrapolate from here and we use the parallelogram method to solve the question. So how are we going to do it? So we extrapolate by having this kind of line. Then of course this one has come here out of 45. We ask yourself, 180, you take away 45, what do you get? What do you get? When you take 180, you take away 45, I think you get 135. So when you take 135, 135 will be the second quadrant. So when we extrapolate like that, this means our angle here will be 135 degrees. Okay. Yes. Now when it's in that direction now, we will now draw from here. We'll draw it from here, from that direction. We extrapolate from 135 degrees. From 135 degrees. Then going to the direction of this way. So this means the angle here is 135, which lies in the second quadrant after we've been given 45, which lies in the first quadrant. Is that okay?
Yes.
Good. Now that one, when we draw like this one, we know the properties of the parallelogram, isn't it?
Yes.
Yeah. When we know that one, this means we can extrapolate and make this angle, this triangle, this figure to be a parallelogram, isn't it?
Yes.
We know how to do that. Or anyone with a problem with that one? Do we? No problem, isn't it? Good. So that one lies under the parallelogram there. No problem. Are we together?
Yes.
Now, when we come to another thing that maybe we call about that's understanding addition, this means that this one you just draw the way it is. You've shown. They want us to show, so you've shown. Okay? So after you've shown like this one, the person who will be dealing with this one will be able to know you are using which type of method of vectors to solve that kind of equation. So I don't see if it's very hard. You just play around with it. Some simple calculation here. You only take 180, you subtract 45, then you get the answer, isn't it? Yeah. Aha. We can have another example that based on the same question, but now we have 7n and that was 9n at an angle of 75 degrees. How do you go about that one? How do you go about that one? The same criteria still applies, isn't it?
Yes.
Yeah, the same criteria still applies. It's not difficult to just sketch using those type of direction you've been given, that 7 and 9. After you sketch now, you know to draw the 75. And you know that 75 lies in the first quadrant.
Yes.
So you extrapolate by subtracting from 180, you get the angle that gives you the parallelogram shape. Are you together?
Yes.
Very good. Another thing that maybe I want us to add over the same learning outcome that I want us also to go through is now how do we add? How do we add? Now we add this kind of addition whereby we have we can have this is addition of what? Of vectors. Addition of vectors. We know that vector is being drawn in x, y, and z, isn't it? So after we've known that the vector is in this direction, it must have xi, yj, and zk, but they are the vectors. Is that correct? So when we have this one now, we come and maybe we need to put them in the diagram. So this is x, this is y, this is z. So here we have the vector of k, here we have the vector of j and vector of I. Isn't it? So when we add this we add from x, we go to y, we go to k. We add in that direction. Isn't it? So, but when we add vice versa, we start from here coming to this direction, we will get something that we did in complex numbers called the I. Do you know how we got I? Just the root of -1, isn't it?
Yes.
So when you find the root of -1, this you will get what? I. That's what we did in complex numbers. So when you go this direction, this one will be negative, this one will be negative. When you start from this one will be negative, this one will be negative. When you start from this one will be negative, this one will be negative. But when you go this way, all of them will be positive. So when we add those kind of calculations that and there's this kind of sums, we have number one. We have now number one, we can say example. So whenever we talk about sum and resultant, are they the same? Are they the same? Sum and resultant, are they the same? It seems to be. So when you talk about the resultant in vector, this means the addition. Yeah. So whenever you say a resultant in vector, they will be asking you to do the addition, or rather they can use sum. But in vectors, we use resultant. Is that correct? So you can have a question that goes, that question we can get the resultant. Calculate the resultant vector. Calculate the resultant vector of -13i plus 14j minus k and 27i minus 11j plus 9k. When we have such kind of sum, or when we have such kind of mathematics in this concept, what you need to do, we know that I goes with j goes with j and k goes with k. So when you add them together, you will find the resultant vector, which will be 1. That's correct. So when we add, we have different ways. You can add, we say solution, we can add this one, -13i plus 14j minus k. We add 27i minus 11j plus 9k. These all are the vectors. We can start by saying -13 plus 27, but this one is I. Okay? Then we add 14 plus -11, but this one is j. Then we add, that's -1 plus 9, but this one is what? K. When we work it out now, when you take this -13, -13 you add 27, you get positive 14. 14i. Then we have positive 14 plus -11. What do we get? Positive 3, is it? Yes. Yeah. So we get positive 3j. Then we finalize by negative what? Is it positive or negative? Positive 8k. isn't it?
Yes.
So that's the resultant, the resultant of that vector. Or rather, alternatively, you can arrange it like this: negative 13, 14, and negative 1. But here it's I, J, and K. Then we add, that is 27 minus 11 plus 9. So this is positive. Because we are dealing with vectors, whenever you write like this, there's no problem, isn't it? So this is in unit form and that's in the vector, in the coordinate form. How it is. Now when we add this one, this I, J, K, you will find that you get the same answer. So this one will be 14I, that is 3J, and this one will be 8K. But now, in unit, you don't include this one. Yeah. So, you remove this one as you put them in there. Is that one understood?
Yes.
So, you can work out this one. You can work out this one. You can work out this one in groups of 2, 2. Then you work out this one. So the values are going to change. The values are going to change. They are not the ones we used. We are going to have that's negative 13 I plus 17J minus 7K. That is 29I minus 7J. Then plus K. So when you work it out, you need to get the answer. So that is negative 13I plus 17J minus 7K, as we add 29I plus negative 7J minus K. So you can discuss with your, you can work in groups of 2. Work in groups of 2. You work in groups of 2. In groups of 2. You talk to your neighbor. You don't have a neighbor, you discuss.
Ini kamera yake iko chini, kamera yake iko chini. Sawa.
Have you got the answer? Have you got the answer? What is the answer?
15.
Who can work it? Who can work from the board? Yes. Very sharp. Okay.
Let's create a likeness of which I was 13 to
has done, that's negative 13 plus 29, but I in bracket. Then negative 17 minus 7, that's J, isn't it?
Yes.
Then she has come to negative 7 minus 1. You get the answer, isn't it?
Yes.
That's good. How do you appreciate it, sir? How do you appreciate? Good, that's good. And alternatively, who can do it using another? That is it, correct. Let us appreciate now. Good. Now, up to that point, do we have any problem? It's well understood, isn't it?
Yes.
So from there, I think we are good to go. I can give out the assignment, isn't it?
Yes.
Let's sing on the same. And the assignment will mark in our next work. Isn't it?
Yes.
Now let us have assignment. 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 Question number 1. Let us say. Write the coordinates of the following vector. In unit 4. So this is the first one is negative 11I plus 3J plus 1K. This is A. Then B is negative 1, or rather negative I minus 17J plus 7K. That is our assignment, so ensure you work it out and we'll mark in our next one. Class. Is that correct?
Yes.
After that, will we have any problem?
No.
Any issue?
No.
Are we good?
Yes.
You've understood?
Yes.
Briefly, who can remind us what we've done? Briefly, before we leave, what we've done? Yes? Addition of vectors, that's good. What did we say about addition of vectors? What did we say about addition of vectors? Yeah, yes, Lina? Very good. It's the same as the result in vectors. Is that correct?
Yes.
Very good. Another thing that we've discussed. Another one. Yes. We've done more than 2 things. Yes. By differentiating the vector and the scalar. What did we say about the vectors? We said that the vectors deals with what? Direction and magnitude. And the example is what? Time and temperature. Lastly, we've done also the scalar, and we said it has no direction. And the example is the volume and the acceleration. So at that juncture, I think you are good to go. So we meet next time in our next session. Ensure you work out your assignment. It will act as our first cut. Are we together? Yes. It will act as our first cut that we will record. So ensure you work it out. Are we together?
Yes.
So I wish you all the best. Have a nice day.
Thank you.